New Zealand is infamously located along a subduction zone, along where the Australian and Pacific tectonic plates meet. This tectonic friction caused the uplift of the Southern Alps over geological time and makes the country prone to earthquakes. The 2011 Christchurch earthquake, a 6.3 on the Richter scale that killed almost 200 people and caused devastating damage to buildings, was a tragic reminder of this geological fact. In response to this tragedy, seismic building codes were updated to reflect the hazard posed by earthquakes in the hopes that future seismic events can be mitigated in comparison. Early warning systems are now available for earthquakes. These are even available on certain Android phones, allowing people to move to safer ground in minutes before potentially violent shaking occurs. The company Geological operates a network of P-wave detecting P-alert units that are used by councils, universities, district health boards, ports, and power companies. These P-alert units can be purchased online, with several units recommended for a single site. Building information modeling (BIM) software and other forms of 3D modeling can be used by engineers to accurately estimate how structures will handle different types of physical forces and stresses. This includes the mechanical force of a seismic event at a given depth and magnitude, as well as forces from freak weather events like gale force winds, storms, or heavy snow. The accuracy of this will depend on the fidelity of models as well as the accuracy and precision of event data. Two earthquakes of the same magnitude and depth can have very different effects, depending on the location's geological circumstances. BIM software, in conjunction with motion sensors, also has the potential to track the location of people inside buildings in real time, which could prove helpful to locating survivors in the event of a fire or building collapse. However, this may represent a privacy issue for some people, especially in regards to bathrooms and changing rooms. There is a wealth of knowledge available online on how to best respond to different emergencies. Much of this is common sense, such as avoiding standing under glass during an earthquake. Other questions are more obscure, such as what to do if you are high up on scaffolding when an earthquake happens or operating heavy machinery. Checking building codes and regulations to ensure a building is being built or renovated to withstand earthquakes is easily done online. The same is true for checking weather patterns and the likelihood of potentially dangerous events, such as extremely low temperatures, heavy rain or snowfall, black ice on roads, gale force winds, or flooding. Site-specific safety plans are best used on digital platforms for accessibility and keeping information up to date. For more information on how to manage earthquake-prone buildings and what your obligations are as a home or building owner, to see if a building is registered as earthquake-prone, or to learn more about emergency response planning, follow the links in the learning summary.